Okay, this section is about the Hinge theorem, and that's in section 5.6, so you can use it. It's very similar to the triangle inequality that we studied in section 5.5, but it involves more than one triangle. So before we learned that the shortest side of a triangle is always opposite the shortest angle, and the longest side of a triangle is always opposite the longest angle. But that would never help us with two different triangles. Like here, the shortest side of this triangle is opposite the shortest angle, but that shortest side of this triangle is still longer than if I make a really small triangle that has a large angle. You can imagine that if that's a really small triangle, the largest side of that triangle is still shorter than the shortest side of this one. And similarly, if I make a big triangle like this, the shortest side is opposite the shortest angle. It's right here, right? But that shortest side is still longer than the longest side of this one. So all we did in section 5.5, all we did with triangle inequality was limited to one triangle at a time. And for us to apply this theorem to a situation where there's two triangles, we would have to know that those two triangles had the same two sides. Like the opposite side of one triangle is going to be similar size to we can compare it to the opposite side of another triangle only if the two sides are the same. So in this case, up here we see that RS is congruent to VW and ST is congruent to WX. Therefore, we can say, okay, since the sides are the same, now it works. The biggest side is opposite the biggest angle, and the smallest side is opposite the smallest angle. But I can only say it because I know both the sides. Similarly, again, since I know both of the sides, but the distance between those sides at the end, here it's bigger than it is over here. That means angle A is bigger than angle D. All right, let's see this Hinge theorem in action. This problem asks us to compare AB and CB, as if to say, which is bigger? Can we do so? AB is right here, and CB is right here. So which is bigger? Well, look at what we have. We have the angle opposite these two things, and well, we have AD given to us as congruent to DC. That was given, but we need two sides. We need two sides. Well, these green sides are, we do have two sides because they both of the green sides are cut by DB. So now we have, and DB over here as it relates to this triangle is still congruent to the side. I mean, it's still itself when it comes over here and makes part of this triangle. So now I know that since I have an angle, I have two sides that are congruent and two sides that are congruent, then I don't know, I'm trying to compare these two green sides, and one of them is opposite a 92-degree angle, and one of them is opposite an 88-degree angle. So I think the one opposite the 92-degree angle is going to be bigger. So CB is going to be bigger than AB is opposite only an 88-degree angle. So AB is less than CB. All right. Next example, I'm being asked to compare the measure of angle 1 and the measure of angle 2. So 1's right here, 2's right here. Again, same idea. They share. 1 is in between the red and the yellow. 2 is also between the red and the yellow. 2 cuts a side that is 16 in length. 1 cuts a side that's 15 in length. Therefore, 2 is bigger, angle 1 is less than angle 2. One last example. All right, this time we're being asked to compare TU and VS. TU is over here, VS is over here. They're both opposite, again, 2 equal sides, right? They are formed by a triangle opposite with 2 equal sides, and they have an angle that cuts them, and the angle is identical. Guess so. Therefore, if those angles are identical, then the sides must be identical too. So in that case, I would say those are equal. And that's going to be all for section 5.6. Thanks for watching.